Let's look at how we measure temperature. For the period 1880 to 1980, the United States had the best temperature record in the world using calibrated thermometers and logbooks. Europe went through 2 wars, so they don't have much continuous data, and the rest of the world didn't have reliable measurement. There are 8,000 weather stations in the United States, and 1,200 of them are special. These are the members of the U.S. Historical Climate Network, a group of stations that have been producing consistent temperature readings for more than 100 years. It's boring work, but it's important, and I want to show you some of those stations. Here's the station in Orland, California. It's still far away from any heat sources. Its average temperature readings show very hot years during the Civil War, 2 hot decades in the 20s and 30s, a general cooling trend, and then some recent warming. This thermometer used to be out in a field until they built an airport around it. Do you suppose it reads hotter than it did 100 years ago? This one hasn't moved in over 100 years. This one was in a field until they decided to put a building on top of it, so they took it upstairs to the roof near the heating and air conditioning exhaust. This one had a firehouse built around it, and its temperature record shows rising numbers starting around 1980. How old does that building look? This is called the heat island effect. Temperatures haven't actually risen, but thermometer readings have. Out of 1,200 stations that began recording before 1900, only 13% are rated 1 or 2, shown here as blue and green diamonds, which means they are providing consistent data. The rest have been significantly compromised. How does that affect the U.S. average temperature? Well, we don't measure average temperature. There's no such thing as an average temperature thermometer. We measure the maximum and minimum each day. If you look at the unadjusted data, you'll see that the maxima have come way down since their peak in the 1930s. There's been a general decline in peak temperatures for the last 100 years. But unadjusted nighttime temperatures have risen. How could that be? Because most thermometers are now in urban neighborhoods with plenty of asphalt, brick, and steel. These structures absorb heat during the day and radiate it at night. Only weather stations that are still isolated show the cooling trend, while the rest are reading hotter and hotter. So the warming here is a warming of urban thermometers, not the warming of the climate. Now look, please pay attention. This is a graph, and the next graph are going to show 2 different ways to look at the average temperatures. This one is NOAA's graph of extremes, which is a single number for each year, calculating the temperatures either significantly above or significantly below normal. Seen this way, it looks like the last few decades have been getting warmer and warmer. But if we just look at hot days, not some peak temperature out of the year, we see a different picture. This data comes from the same sources, but now we see the number of days above 90 degrees, shown in blue, 95 degrees, shown in red, and 100 degrees, shown in yellow. The number of hot days represents the climate much better than a peak measurement from each year. The 1930s really were hotter. The general trend is down, and Tony Heller has verified this by correlating this data with stories from newspapers in each of those years. Looking outside the U.S., Iceland has decent records because they weren't involved in the wars. Here is 200 years of continuous records from a remote site that hasn't been compromised. It shows an increase of less than 1 degree centigrade per century. I don't see any hockey stick shape here in Iceland. Do you? Let's go back and try to establish the best possible temperature graph for the last century. In 1999, NASA and the UN published a graph that looked like this red one, showing average raw data from the U.S. Historical Climate Network. And then they said, hold on, we have to adjust our data. They adjusted their data several times, publishing new graphs every few years. And they now claim this blue graph is the truth. They cooled the past and warmed the last 15 years. Remarkably, the difference between these two graphs exactly matches the increase of CO2 in the same period. Coincidence? You know, I don't think either of these graphs represents reality. I think NASA has adjusted their data to match the narrative of global warming. But I don't think the red graph represents reality either. If 87% of these stations have been compromised, then this graph has to be reading too hot. That makes NASA's graph, which cooled the past and warmed the last 15 years, even more wrong. To me, that says NASA is in the storytelling business, not in the science business. So I've looked for a graph that corrects the raw data for the heat island effect, and I can't find it. I've asked around, and no one has it. So I've created an estimate by adjusting the temperature down, starting in the 1960s, to account for the hot readings from the compromised stations. This may not be right, but whatever the true temperature history is, it must be cooler than the average of the historical stations. It can't be hotter. You may want to pause here and look at these three graphs to understand them. Red is the average of the raw temperatures. Black is constructed to estimate throwing out compromised data from the hot stations, while NASA's graph has evolved over time to become this fictional blue line. Keep these tricks in mind whenever you hear hottest year on record. Let's move on now and look at Arctic sea ice.